Good afternoon, everyone. In this session, we are going to talk about the emerging technologies in civil engineering. Uh, all the branches, other branches, before they go into the application area, they have to get housed in a building. The cities we develop, they get connected by bridges. The water you drink has to be again under the previous civil engineering. So, a lot of branches of civil engineering are, touching upon each and everyone's life. But the major certain issues in the today's time in the context of our country is that we have been taking a leap into the infrastructure development. And right now we are at the verge of developing the smart cities. So all of them are basically to provide a basic infrastructure for meeting the technological requirements, which are so paced up that communication, movements, and everything has to be go at very fast manner. And then you need to take a lot of concern about the environmental degradation which has been taking place due to the developmental activities. It's primarily because of the excessive demand and excessive requirements, and particularly our country faces that issue due to the overpopulation. So once you have a pressure on the resources, thereby we need to take up the technology which would lead to the sustainable development. The word sustainable development has been talked more than one platform and every area, but in today's talk we are going to give you some demonstration also that where we made them applicable in addition to the areas where they are being useful. So various areas where emerging technologies need are taking place: building construction, bridges, roads, then structural monitoring, dams and irrigation, water supply and sanitation, and there are miscellaneous areas like tunnel, metro, etc. Out of these, if you see, I've listed only those which are very prime and very important in all aspects. Now, whether you are talking about building or bridges or pavements or any of the discipline areas, how do actually we are looking for the emerging technologies? One could be, the betterment of a quality product. The second could be that faster pace of construction. And third could be that environmental sustainability is one of big aspect. So to do the basic principles or techniques which involve all these is, so the first basic technique is recycling. We will see how recycling is helpful. Second is a prefabrication. Then third is green materials. And fourth is energy efficient materials. The energy efficient materials and green materials are slightly different. And then comes certain other materials or additive which need to be used in conjunction with the traditional material, or which may be a new material, or which may be simply an additive to prepare the materials like concrete itself. Concrete is one of the largest building material which is used all over the world, and it is one among the ancient material as well. And without necessity to that, it is important. What has taken place is that from the traditional concrete which we have been understanding, we have been trying to achieve a kind of material that it serves the same purpose, but maybe a lightweight, because nowadays there's a lot of the earthquake coming up. So we all understand, the lighter the material, the lesser would be the damage if anything falls on you or touches that. Unfortunately, the techniques which are suitable in India, they are more relying on the heavy building material because of the safety reasons. If you see in the US or other countries, they prefer to build houses of wood or other lightweight materials. But unfortunately, they are not secure in our country, so they can be easily broken into that. So similarly, if you take the example of Japan, they build the lightweight construction because every day, every second day, they are having the earthquakes. So a lot of learn from them. Concrete requires a lot of consumption of material, natural resources like aggregate. Then cement production is one of the prime thing, which is again obtained from the natural material using lime and other resources. And traditionally we have seen that from the earlier mixers we are coming to the ready mix concrete, where the concrete is now prepared into the plant, then brought at the site in a kind of what we say is a tanker type of the thing. Then it is pumped. Now you have a machine which is pumping that and putting into the formwork which is already there. So that is a basically improvement which has taken place for the sake of better quality. And then secondly, for the sake of reduction in the environmental pollution at the site. So pollution reduction takes place because it's less noise if you're not running any machinery there. Now, wherever the constructions takes place, we all know that there's a lot of noise taking place. So people try to avoid, and people, if there's already rehabilitation there, habitated area, so all people are disturbed. Now, self-compacting concrete is one area which doesn't require the use of vibrator. We all know the vibrator is used. Once you put the concrete, you use the vibrator so that it gets compacted, the voids are being filled up. So that's very common technique we have been following. But this is the one that by making certain simple changes into the ingredients, that the moment actually you have prepared and you have put into the by forcefully pumping the concrete into the mold, whether it's a column or beam, so you don't have to apply any compactive effort in form of a vibrator. So what is it going to help you? It is going to save you the energy. It is going to save the pollution which is taking place. So that's one new emerging area in the concrete technology. The second is bacterial concrete. Now that word itself may be looking slightly odd. Bacterial concrete, yes. Bacteria being added to concrete. What it does in the sealing effect, means reduction of the voids. We have seen that despite of good construction, but certain sometimes poor practices, that if you have not done the curing properly at the site, concrete requires curing for 3 weeks at least. Try karte hain so that is for the purpose that it gets cured, then it gets compacted well, it gains strength, and we have seen sometimes the patches of moisture. So this is going to control. It is going to see the bacteria in itself grows within that, for a certain period of time, and we'll see. So that is the bacterial concrete, which is the new area. Epoxy concrete. If you have had a old construction, maybe a column, building, slab, bridges, anywhere. So any structure is going to deteriorate after a period of time. So what do I do? Whether I demolish it, build it again. You have seen number of bridges getting old, the traffic movement becoming heavier, earthquakes may be damaging. So in a whole building, it is terribly difficult, to demolish one particular component which might have deteriorated, because you need to give support. They are all interlinked. So in that case, epoxy concrete is a technique that by using certain epoxies, you can combine the existing concrete with the new concrete so that they act as one member. So you can increase its strength, the sizes, by increasing the size or whatever. The use of fibers. Now, as I said, that we are looking for the lightweight construction. Lightweight construction, traditionally we have been using the reinforcement, steel reinforcement, to increase the load bearing capacity of the building component. So steel is a heavy, so you can't avoid. So fibers are one, because steel is distributed only in a particular direction. What the fibers do, that the fiber get uniformly combined, so they are distributed uniformly wherever the natural concrete mixture is. So fibers may be steel fibers, it could be made from plastic fiber, or any different type of fibers are there. So they are being adopted, of course, and they have been found to be successful and enhance the properties of the concrete in terms of the strength as well as the durability. Another area is that concrete consumes, any plastering or concrete works, they consume a lot of water as well. So treated water, the one which is from treatment from the plants, domestic waste water which is treated. So one usage of that water is for irrigation. In Chandigarh, for example, they use it for irrigation for the rotaries. All the second, this was tried out over here. So it was found that treated water, tertiary water, that can substitute actually the normal water for consumption in the concrete, for preparing the concrete. So the studies were successful, and they found that in few of the parameters, rather the concrete prepared from treated water, it performed a little better than even the normal water. And the demolition waste is one of the biggest problem which is happening. I'll show you that we use where did we use the demolition waste. I have a study for the roads but not for the buildings. But demolition waste is that nowadays there may be requirement, or there may be people want to go for new fashioned or new type of the houses. So glass is coming up, replacing fast the wall. So they will demolish part of that, build up new one. But what does happen to the demolition material? Mostly it is just dumped outskirts of the city. So there are techniques that if you properly segregate the waste and find out its properties, you can find its usage as well. Lot of other waste materials like fly ash, pond ash, which comes from the thermal plants, and other similar type of the factories usage industry, like foundry sand. Foundry sand is where you have the sand is being used for mold purposes. Then it gets heated up and then loses certain properties. So foundry sand, then it's finally discarded by the industry. Similarly, we have materials like you have the marble industry. So when you have the cutting of the marbles being done, so the powder goes waste. So it is dumped like a form of the slurry. So the biggest problem is not simply that we want to save the money. The key issue is that we want to conserve the environment, because all these materials, waste materials, either they be put into the water body like a slurry, for example, the marble dust slurry, or it will be putting the landfills. Land is also very important. So for example, if you do the in a Chandigarh, if you do on the outskirts, tomorrow after 5 years you need to expand the city. So what do you do? Are you going to remove it again, or what you are going to do about it? Another area which is touching upon is that prefabrication. Contrary to what we have been traditionally doing over here, was that we were building at the site whatever plans are there. So prefabrications mean that you build a component not at the site but in a factory, just like you make a component of a car, and then bring it to the site and join them together. So what is going to help it? It has already been used in building and bridges, and it helps you to do the construction in a faster manner, with so much of the emphasis on the Swachh Bharat scheme, where you want to build up the toilets, and secondly on the housing for the poor. It is that if you do it traditionally, it is going to take another 30 years to meet the present requirement. But if you do in the prefabrication manner, that period will be reduced. You can't do it traditionally, because all component, minimum, even if you do at the pace it goes by, I need 3 weeks of curing to do a component, any column, and before I actually extend it. But if this is made in a factory prior, I just need to bring it at the site. Everyone knows, there was big news, if they remember, in Mohali, they built 6-story building over a period of 48 hours. Of course, it requires a lot of meticulous planning, how the components are going to join, and then it becomes trademark. But yes, it is possible. So it has been done. So that's why it has been done. Why not it is being done on the mass housing? There are certain issues. People need to be educated. People need to become aware. They need to build up confidence that these are safe as well. Unfortunately, we always are a little slower to the changes. This allows relocation. I mean, if I do a prefabrication building, smaller units, tomorrow I need to shift it, I can do it. I'm going to show you 1 or 2 slides. For example, in military, in our country, in this part of there, now our forces are retreating back because this is frozen. The ice is, the snow is so heavy in certain areas, Kargil areas. So you need to move back. So what do you do with those housing activities? Are you going to allow them to be buried under snow, get damaged? So they can be relocated. If you have done the prefabrication techniques, they can be relocated. You can just take it out and bring it over and fix it over there. Better quality, because now I'm no longer working in the open sky. I'm working in the closed shed. So it is covered. So more control is possible so better quality would be obtained. Better working condition, because the labor is working inside and not exposed to rain, heat and cold to the extent. So the application is greater for defense, hutments, shelters. Like for example, you have a disaster coming up, earthquake coming up, hitting a country, and 10,000 people, or a flood coming up, 10,000 people need to be relocated. You can't have housing built for 10,000 people over 2 days or 3 months. So by that time it will be over. So prefabrication helps over there. So you can put the blocks, and that's one simple thing. It's a under completion building. The slide please. Okay, so it's under completion building. So you can see that only the roof is to be placed. The only issue with the prefabrication is that you will not have too much of the choice, architectural choice, designs. It will be a duplicated, a replica, like here. So this is a quick one. It doesn't take more than a week to be prefabricated. So that's one example. You have on the defense, the barracks for the soldiers being in line. So you will find that they are similar. Their very design is very similar, but it will have prefab door, prefab windows and everything, but not. So if I want to relocate this, I can easily take it out. Then this is something an observatory on a very high hilltop, or maybe in submarine area or desert area for defense purpose or for observation. So if you were to take bricks over there, if you were to take cement, everything, all those ingredients over there, it would not only would have taken a lot of time, it would have been very, very expensive to bring the labor from there, or even the adverse conditions like the snowfall areas, heavy snowfall areas. So you have the prefab components. You can see very easily that simply some angles are being fixed into the ground, and then this observatory or a room that is being prepared over there. So in the remote areas and difficult approach areas, it is one of the boom. That's a crane which you need just to do the fabrication of a little bigger one. So up to 3-story buildings can be very successfully done easily. Beyond 3-story, of course, you need some special measures or techniques, but up to 3-story, it is very, very convenient, which you can do. So you may require 1 crane or sometimes 2 cranes just to pull up the components and allow them to be placed where they are meant to be. Okay, now green materials, green materials, green buildings, green technologies are different words which are buzz up nowadays. So what exactly green materials means? They are not green in color, everyone knows that. But green materials basically mean that what we are looking for is that we are in totality aiming at the reduction of energy consumption, and from the point of the production to the application. आपने कोई material produce करना civil engineer, जैसे bricks हैं, so you are that's a conventional material. So bricks would require, we all know, उसका brick kiln चाहिए. So you are going to burn lot of fuel for that. So it's energy consuming. So energy consumption means more of a pollution coming up. So can I produce a similar type of material, manufacture that type of material without necessity of burning so much of the calories, without producing so much of the waste gases which are going to cause the pollution? If you can do that, that is what we are looking for, a green material. That is the basic concept. The material which will consume less energy, produce less carbon footprints, and of course nanomaterials are also being added to that. So that's green materials are now gradually being developed, coming up, and for the same reason, for the one reason, because the natural sources, like if you have to make a brick, so I need clay. So clay is a natural material. If you are going to make concrete, so I need aggregate, cement. They are all natural sources. And natural sources mean, either you are going to do the excavation, you are going to remove them from the riverbeds, or you are going to dismantle some of the hills. And in Rajasthan, of course, the requirement of marble has already devastated certain ecological balances. So it is already done. And if you remember that in the states of Haryana, Punjab, the mining is banned for those same reasons. Mining may be bad, but what about the construction? You are looking for more construction. You are looking for more housing, more roads, infrastructure. They are not stopped up. So what do? You have to look for alternatives. Energy efficient materials or techniques are slightly different from the greener. When I say techniques, I'm actually using the conventional material, but slightly making some kind of amendment or modifications. For example, perforated concrete. Perforated concrete means concrete having the voids. They are filled deliberately with the air, and we all know air is an insulation. So if you have a kind of hollow block construction, so what will happen is that your air conditioning requirements will reduce. So if it is too hot outside, the hollow block or perforated materials, they will not allow that heat to be transmitted inside. So likewise, the same will happen in the cold condition. So ambient temperature conditions are produced, and your energy requirement to heating or cooling, they will drastically reduce using the perforated material. So likewise, then fly ash bricks. So adding fly ash in the production of bricks. Fly ash has been the waste material, and by this time, so much techniques have been developed that fly ash is picked by the cement industry. They use in the production of cement, and in fact now it is being sold out. And that has been the growth. Earlier, fly ash was available free, so you only have to do the transportation. But now looking into the demand, then they are also charging some money for that. So cement industry picks up the whole fly ash. So we hardly get for. So what is left is the pond ash. Pond ash is the one which is left out because you were using water sprinkler to reduce the pollution. So the fly ash gets mixed up with that, settles down, and then dries up. Then it becomes the pond ash. Then of course solar energy in heating and cooling is one. In geotechnical areas, it is extremely important to maintain the ecological balance. We have two requirements major. One is that you need to use the wastelands, for example, in Bombay, or what happens is that when the cities expand, the outskirts of the city have been earlier used for the dumping purpose, so organic domestic waste. They become organic. Now you want to expand the city, so you want to reclaim those lands. So how do you do that? I can't build a foundation building on a weak soil because my building will sink. So what do I do? But the land is, if the land, because of its proximity to the city, becomes prime land, if I can use that. So there we have to come with the solutions where we can be using either the strengthening of the foundation soils. So what we have is, we have got some chemicals now, like RBI, which is produced by company Alchemist for the medical reason, but the same company sister concern is producing chemical. So it will enhance the soil strength by 10 times to 20 times. But you need to properly evaluate and find out the dosage, what kind of quantity. So I can use that because it's not expensive. You spend some money, but then you reclaim the land. The other solutions are geosynthetics, like geotextile, geogrid, geomembrane, geonet. They are either used for strengthening purpose of the soil, or one of the prime area is stabilizing the hill slopes. Because of the rainfall or instability, the slopes are not stable, so a lot of hills get destroyed. Lot of the fertile soil, top cover which is fertile, that gets lost, so you have a dropout in the agriculture produce. So there the stabilization can be done or protection can be done using geotextiles. They can be simply either fixed on that, or there are many other techniques. So similarly, geotextile for improving performance of roads can be done at different application areas. So geotextile, geogrids, geonets, geocomposites, they are different variations of them. And geogrid is something like, it's just like, if you see a garden, so there's a fencing done of a mesh type of that. So it's a kind of that. And geosynthetic is similar to your what we use a sponge for the cleaning of the utensils. What's that? Green colored sponge is used for the cleaning. So it's that similar kind of material. They are of course made from the special ingredients because they are going to last for 20 to 50 years. So that makes them a bit expensive. Geomembranes, for example, they are just like polythene sheets. So if you want to save in irrigation, we have the canal, so a lot of water gets drained out because of the seepage. So if you are, it may be 25 to 30%. So if you use a geomembrane, just do the lining with the geomembrane. So only losses will be evaporation losses, no seepage losses. So spending money for those, because water is also becoming scarce. So spending money on these techniques, they become very, very handy and useful. I'm going to give you a little more detailing about one area like pavement. Road infrastructure has seen a lot of growth, and if you see the present government, they have doubled the number of kilometers constructed per day from the day they assumed power within a short time. So it was 8 kilometers, now 16 kilometers per day. That's the target in national highways and state highways. So doubling up that. We need not only the material to build the infrastructure, we also need them to sustain and maintain. So we'll be requiring them to top up because of the additional traffic requirement. So what you have is a kind of surface course, which is 30 to 50 mm at the top. And if every 4 year or 5 year, it will develop cracks or that, because it has a useful life. So what normally people do is that they'll put another layer on that. And then at some stage of time, it becomes very, very thick. And when it is passing through the habitated places, then because of drainage problem, then you need to remove that. Or with the development, you need to relocate the highways. So what do you do with the old materials? You have been discarding them so far. But now, because the overlay, if I give you some example that, you need so much of the expensive, and every 3 to 5 years you have to work up with some layer which is demanding a bitumen of 5 to 5.75%, and bitumen costs also raking up. So I need to conserve the material because aggregate need to be saved, and natural source, we already mentioned that, and it is threatening the river beds and mining both. So this is what technique was earlier done. You would demolish it for certain reason and throw it out. Why we throw it out? Because I can't use it again, because it is in form of the lump. So what I'm going to do is I improved it to this extent, but finally I need the aggregate in this form before I can reuse it. So what we have done is that now we have got the milling machines. The milling machines are fixed with the diamond teeth. So they will directly chip off the material in finer forms and produce the material in the form you see over here. So this can be mixed up with so that is the old material. So what I'm doing is I'm removing the layer, putting it into aggregate form, and then mixing with some new materials, adding bitumen, and then relaying it back. So in this process, I save two things. One, you save actually the aggregate material itself. The second, if I needed say 5.5% of the bitumen, I may be now doing with the 4.5% of the bitumen. So this will be saving 1% of bitumen. So 1% of bitumen saving means it comes in the terms of lakhs of the rupees per kilometer length. So bitumen cost is nowadays something like 60 to 70% of the total road cost. Earlier it used to be different. It costs you something like 36 rupee a kg. So saving 1 rupee, 1% of the bitumen is very, very. And second, the biggest thing is that if I am not reusing it, where I am dumping it, so I am either spoiling the land because it is not going to be used anywhere else. And if it is too old and pavement, then I'm going to use in the bottom layers. So we did a lot of studies, and all over the country and world, the studies have been done. And it is found that up to 30 to 35% of the old material can be used in the bituminous mixes, and up to 40% of the material can be used in the granular layers, mean the bottom layers. When the aggregate, when the pavement is very, very old, then it goes. So that's one example. And then just to mention that 3 studies which we did over there, This was a case that we had a demolition waste in one of the area, which was a building, college building was coming up. So what we did was, the demolition waste was crushed under the roller, and it was used as one bottom layer. So we saved 150 layer, whole of the road and the parking. So that was done. It was done 8 years ago. It is working perfectly. Then another case was, reconstruction. So when you were removing, so we encountered big boulder. The specification said no, you can't use something like more than 75 But then we did some study and we reused each and every material which was removed from that site. So bottom layer was made from that. So you need to actually use your ingenuity and come up with the solutions. The codes or guidelines, they are meant to be guidelines, but they are not the dictators. So if you are confident that the performance can be achieved, so why not do that? So you have to use, that is the engineering, economization, giving the solution. So similar cases have been done, and we did the post studies also, and they have been found to be performing quite well. So thank you so much. I believe that since we lost a couple of minutes in the beginning due to interconnectivity, so if you have some question, you can ask me, else I am going to close that because the new speaker is already here.